Welcome back. Okay, this is the beginning of Module 3, getting started. Let's drop down from our broad level overview of relevant water quality policy and issues. Module 3 here will focus on specific things any IDAH2O Master Water Steward needs to know and do before starting out assessing streams or ponds. First, we're going to look into the nature of watersheds and how they are mapped and organized. And second, we will demonstrate the parts of a monitoring plan. With these knowledge sets, you'll be ready to plan out your own water quality monitoring. All right, let's get started. So IDAH2O takes a whole watershed approach. That is, we recognize that everything that happens in a watershed will affect a stream in a positive or negative way. A watershed is defined as an area of land that all drains to a single point. That point is usually a point in a water body, like the confluence of two streams, or the inlet to or outlet from a lake or pond. The mouth of a river into the ocean is the ultimate point from which to draw the boundaries of a watershed. Using watersheds helps to understand how water flows across the landscape. If a pollutant, for example, shows up lower down in a watershed, one only needs to follow the stream up until the individual tributary with the pollution source is found, instead of searching randomly at every stream that contributes water to the larger water body. Water falls onto the ridges and other high country, then drains by sheet flow into a nearby small stream. Some of that water filters into the ground and emerges as springs farther down the hill. Some of that soil water doesn't emerge quickly, but instead percolates further into groundwater or aquifers. Sometimes the geology of an area sends groundwater into a different watershed than where the precipitation, the rain or snow, first fell. An example of this is the Pend Oreille watershed and the Spokane River watershed. The Clark Fork River empties into Lake Pend Oreille, which then in turn flows into the Pend Oreille River. The Pend Oreille River flows west and north to a confluence with the Columbia River at the US-Canada border. The majority of the lake's water flows into the Pend Oreille River. However, a significant portion of the lake's water, about 43 million gallons per day, in the southern end near Farragut State Park, instead percolates into the gravelly, sandy soil and into the Spokane Rathdrum Aquifer. This water eventually flows underground into the Spokane River and ultimately to the Columbia River farther downstream from the Pend Oreille Columbia Rivers confluence. This same lake feeds two different rivers, one of which is not at all connected via the surface. Now, to keep things simple, for our purposes, we will focus on the surface land features to define a watershed. As the water flows across the land's surface, small streams converge into larger streams, and so on. Watersheds are therefore nested, meaning that one large watershed is made up of multiple smaller watersheds. Watersheds can vary in size, from the smallest being, maybe an acre, maybe not even, providing only enough water for a little seep or dry stream in the summer. They can be enormous. The Mississippi River watershed comprises about 40% of the contiguous U.S. The Columbia watershed within the U.S. is about 7.4% of the contiguous U.S. land area. The Columbia Basin can be broken down into multiple smaller, but still huge watersheds. These include the Snake, Spokane, Pend Oreille, Yakima, John Day, Deschutes, Willamette, and others. Each of these in turn can be further broken down into yet smaller watersheds. Because watersheds can be viewed from large to small, in the United States we assign a similar numerical code for each watershed. Just as every house has an address, every watershed has an address called a hydrologic unit code, or HUC. We sometimes pronounce it HUC. These codes are written in sequences of two numbers and grow longer as you work upstream into smaller watersheds. To start out with, the contiguous U.S. is divided up into 21 major geographic areas or regions. I'm quoting from the USGS website here. These geographic areas contain either the drainage area of a major river, such as the Missouri region, or the combined drainage areas of a series of rivers, such as the Texas Gulf region, or the rivers that flow out of the Coast Range into the Pacific Ocean, which includes a number of rivers draining into an ocean. 18 of the regions occupy the land area of the conterminous United States. Alaska constitutes Region 19, the Hawaiian Islands are Region 20, and Puerto Rico and other outlying Caribbean areas are Region 21. The second level of classification divides the 21 regions into 221 subregions. A subregion includes the area drained by a river system, a reach of a river, and its tributaries in that reach, a closed basin, or a group of streams forming a coastal drainage area. The third level of classification subdivides many of the subregions into accounting units. Now, we don't dwell too much at this level of classification. We'll call that the HUC-6. The fourth level of classification, which we call the HUC-8, is the smallest element in the hierarchy of hydrologic units. This cataloging unit is a geographic area representing part of or all of a surface drainage basin. These units sometimes are called watersheds. These are often called HUC-8 watersheds. Note the map of Idaho to the top left of the slide. Here, this one. That shows the HUC-8 watershed boundaries. Now, they look pretty big, right? Now, let's go to the other map. It shows even smaller watershed delineations. Now, these are at what we call the HUC-12 level. You just continue adding 2 digits, delineating much smaller sub-watersheds. Now, these are much more easily understood simply by driving around and understanding the geography of your area. This slide also demonstrates how the HUC addresses can get pretty long. The 12-digit number that makes up the Cougar Creek watershed and also the Spokane River watershed starts out with the same 17 and then continues on with common digits until the last two make up the unique numerical code. In this way, almost all of the land in the U.S. falls within a designated watershed. There are a few exceptions where small areas fall outside of any watershed, but these are rare enough not to concern ourselves with now. Knowing your stream's hydrologic unit code is only one step toward precisely locating and describing any stream or pond monitoring site. You will also need to georeference your site location. This means that the IDAH2O program needs to know the precise geographic location of your monitoring site using latitude, longitude coordinates. This can be accomplished using a GPS handheld device or a smartphone's GPS capabilities. Handheld devices and smartphones, however, are not all that precise, especially if you are under a heavy tree canopy. This is because of signal degradation through the forest and because local hills or canyons can block the signal from the GPS satellites. For the most part, you can get a close enough latitude and longitude reading this way, but it might take you some time to get the best coordinates. You can determine your site's coordinates the old-fashioned way using a paper topographic map. The 3.5-minute maps have hash marks along the edge corresponding with precise latitude and longitude. You can use a long straight edge and a good ruler to measure out exactly where your site is geographically. This is a more time-consuming process, but it's a fun activity to do with students who may never have had practice negotiating precise location data or orienteering, or maybe even working with a paper map. My preferred method for determining the exact location is to simply go online with your usual browser and open up Google Maps. Navigate to your stream's site's area and turn on the satellite view. It's actually air photographs, not satellite images. Find your stream's site location and click the cursor arrow directly on the site. Then click on the coordinates that open up in a pop-up window at the bottom of the screen. You will see the coordinates listed then on the left-hand side of the screen in 2 different formats. I will ultimately use the coordinates in decimal degrees, where you have a number with a long string of numerals after the decimal point. The Google Maps will also provide you with the same location coordinates listed in another format, the old venerable degrees, minutes, seconds. This format has the latitude or longitude number followed by a degree symbol, and then followed by two-digit minutes number and a symbol, and that symbol looks like a single quotation mark, and then a two-digit seconds number and symbol. That looks like the double quotation mark. Now, either of these will work for me. There is a third format that is sort of a blend between these two, called decimal minutes. There will be a long string of numerals after the two-digit degrees number, and then the minutes symbol. Again, I will use Google to translate any of these into decimal degrees before I input the coordinates into the hydrologic information system that IDAH2O uses. This can be a confusing task for many people. That's okay. I'm happy to hop on the phone with you, with each of us in front of the computer, to suss out exactly where that site is located. Sometimes it takes a little bit of time and some thinking about it. It's okay. I'm happy to do it. Once we determine exactly where your site is located, I will do some due diligence to try to determine whether the site is on public property. Sometimes private property is intermixed with public property, even inside the National Forest or BLM boundary. I also want to know which district or agency is responsible for managing those lands or streams. I will do this behind the scenes work before I assign you the site and kit. You can help me do this if you are able and confident in this sort of work. Your next step is to provide me with a monitoring plan. You can access a monitoring plan worksheet from the IDAH2O website, or from me via email, or via download from this learning module. Or you can simply write me an email with the components that are found on the monitoring plan worksheet. The following slides will give an overview of what these components are and why they are important. So it's helpful to me and to the program to document the various reasons people are monitoring their water body. I do research on volunteer motivations and on the positive community benefits of long-term community education programs. So having documentation of why people monitor is helpful. It's also helpful for continued development of the program. Reasons for monitoring can range widely. Some people are just curious about their stream. Others are concerned about specific sources of pollution now or potentially in the future. Some want to demonstrate that their investment of time and energy and money into implementing best management practices is working. Or perhaps it's a school science project or a work-related interest, or that you are an angler and want to better understand the stream habitat for fish. No matter, just let us know why you are interested in monitoring the stream or pond. Next, we need to know which assessments you plan to accomplish. The IDAH2O program is entirely flexible. So for instance, if you're an angler who is particularly interested in knowing when the mayflies or stoneflies hatch, you can choose to only complete the biological assessments. Or if you're a school science teacher and want to focus on the stream chemistry like pH and dissolved oxygen, that's fine too, to solely finish physical chemical assessments. In addition to the location, please be sure to assess the safety of your site. A site that's difficult to get to, steep, brushy, or otherwise poses safety issues is not going to be a good site for you to work on. While you may aspire for a more remote wilderness-like location, it's better to collect data more often on a less perfect site than infrequently on a difficult to access location. So how many sites are you planning to monitor? We recommend strongly that you monitor only one site or two sites in close proximity. Once you are comfortable and familiar with the protocols, then you can branch out and select more. Remember always to respect adjacent landowners. Now, some landowners are hostile to the notion of citizen science, though in practice this is very rare. Normally, they're just as curious about how cold the water is or how wide and deep the stream is as you are. Again, the goals of IDAH2O include solutions, not just pointing out problems. Ranchers and farmers work hard for their living, and while allowing cows to access the creek or harvesting crops right up to the bank increases bank erosion and sedimentation, it's legal under the Clean Water Act. Ranchers and farmers care deeply about the land, the soil, and the streams, and many are master water stewards. Keep in mind that even multi-generational farmers have never experienced how the landscape looked with intact riparian zones along the streams, perhaps.
Positive conversations with neighbors are a good thing, which includes listening to the landowners who have worked their land all their lives and hold knowledge and experiences from which anyone can learn. Even if we don't fully agree with some practices, they are sometimes part of juggling the demands of agriculture in the modern world.
Your site selection should be representative of the stream as possible. Now, streams change in their nature along their length. Mountain streams, with all their rocks and steepness and cold water, flow out into the valley bottoms and start to slow down and meander, eventually broadening into bigger streams and rivers. You should select a site that is as representative as possible of the portion of the stream you are interested in. No site is perfect, and especially considering safety and access needs, your site will not be exactly like all of the rest of the stream. But just keep in mind that the more your site is like the physical characteristics of the rest of the stream, the more representative your data will be to that which could be collected from the rest of the stream. Man-made structures can alter the depth, speed, bottom, and banks of the stream, but often your only access point is at a bridge or other hardened man-made structure. Try to take your measurements upstream from any structures, and remember that any such structures can alter the nature of the stream both downstream and upstream. So do the best you can under the constraints presented to you. Getting data from a less than perfect site is better than not getting data at all. You can articulate the site characteristics when you describe your site location, and again during the habitat assessment when describing the adjacent land uses, and in the comments section as well. Most people are interested in monitoring one site on one creek. This method will provide you with a snapshot each monitoring event of how the land uses is affecting the stream. There are other monitoring methodologies too, depending on your goals and interests. Some people want to compare two streams. By selecting a site immediately upstream from the confluence of two streams, you can actually compare them side by side. This is one example of a good reason for selecting two monitoring sites. Another example is to monitor upstream and downstream of some land use. Perhaps you are concerned about thermal pollution from a wastewater treatment plant. You might monitor above and below to see if the temperature changes. Or perhaps you are interested in how well the stream protection buffer is working to keep the sediments out of the stream as you do a selective harvest on your forest property. You can monitor the transparency of the water above and below the site. Finally, some people are interested in how one watershed drainage affects a larger stream. This is a less frequently used methodology, but you can monitor a site on a larger stream and then a small headwaters tributary farther up the watershed. Once you complete your monitoring plan, send that in to the IDAH2O program. You will also want to send in the location of your proposed site. Once IDAH2O confirms the site and approves your plan, you can get started with monitoring. IDAH2O operates under a US EPA approved and Idaho Department of Environmental Quality approved Quality Assurance Project Plan, or QAPP, QAPP. You can find that on the IDAH2O resources webpage. It makes great reading if you're suffering from insomnia. It'll put you right asleep. All right, all kidding aside, it's a highly technical document that outlines the limits of acceptable error in the IDAH2O data. All good science programs have some quality assurance plans in place. Our program has successfully competed for grant funding because we operate under a certified QAPP. While our data is not as sophisticated as other programs, and certainly not as sophisticated as the professionals collect, it still conforms to a specified range of precision and accuracy, and it is important that you collect data in a standardized way and take the time to do a good job. This training and the in-person stream workshop are a part of this quality assurance. This training has not changed since IDAH2O's inception, and I can see whether each participant really gets the proper techniques for collecting stream or pond data. We do this workshop and take the time to teach the proper techniques because we know the old adage, garbage in equals garbage out. So always remember to collect as accurate data as possible. I'm always here if you have questions. The first time you go out, you might struggle a bit to remember exactly how to do some of the protocols. Do the best you can and expect that some of your very first try at data collection might not be usable. But once you start learning the techniques, over time, you will find that you can be accurate and consistent. I am always here to answer questions or provide additional feedback. The IDAH2O handbook also provides step-by-step instructions in the text boxes for each protocol. Sometimes you may need to do some interpretation of the step-by-step instructions for a particular location or situation. That's okay as long as you are consistent about applying that interpretation or technique. We at IDAH2O love to see your monitoring site photos. I will set up a Google Drive folder to house all of your photographs. I will give you full access to the folder so that you can upload photos or can send them to me to upload. I have access to very fast internet. Establishing a photo point can be useful at monitoring change over time as collecting the assessment data in the streams. You can find and download a document about photo monitoring in this module. It's a good primer on how to establish a specific photo point for monitoring. I would suggest an upstream and downstream view from your monitoring site, plus a photo across your transect.
At a lake or pond shore site, take photographs of the bank either side of your monitoring location and straight out across the lake. If monitoring from a boat, take photographs from 4 directions, noting which photo is looking which direction.
You can photo anything you'd like, though. You don't need to be specific about setting up photo points if you don't want to do that much work. Besides, I love the aesthetics of streamside environments, so your photos really do brighten up my day.
Once you have completed the online or classroom portion and the practicum portion of the IDAH2O workshop, and you provide me with your monitoring plan, I will assign you a monitor number and a site number. I have a standardized method for creating these unique numbers.
Each assessment data collection form includes a section for you to fill in some preliminary information called metadata. Now, metadata provides me or any future researcher with some context related to the data you collect. This date, time, your monitor number and site number, plus some other information about who you monitor with. It also includes your brief description of the site. The description should be simple enough for a new person to find the exact site when used in tandem with the latitude and longitude coordinates. Lastly, the forms include 2 questions about whether the stream was dry or otherwise unsafe for you to collect assessment data. As a part of the system's quality assurance, you must add data for each assessment technique before you submit the form online. If you check the stream unsafe or too dry to perform all measurements box, then the forms no longer require you to fill in every data point before submitting. A final note about using IDAH2O forms and websites to collect the data. You are responsible for printing paper forms on which to collect the data. The IDAH2O kits come with a clipboard, pens and pencils, etc. It is possible to use the IDAH2O hydrologic information system via smartphone or tablet in the field if you have good cellular data connection like 3G or LTE. However, many of our monitoring sites do not have cellular data service, and many don't have any cell service at all. Therefore, you should print your data sheets at home before you head out into the field. I pre-print a few of each assessment forms on Write in the Rain paper. This all-weather paper has an acrylic type of moisture shield coating. You can use your regular printer and you can write on it with pen or pencil, even in the rain. It's easy to order Write in the Rain paper online. You can find it in some office supply stores too. Another option is to laminate a copy and use a grease pencil or dry erase pen to write on it. But I worry about smudging it on the way home, and the originally collected data is then gone forever.
You can always take a photograph of your data sheet as a backup in case you smudge or lose it.
I suggest you start a file and keep all your paper data sheets just in case. It's a practice most researchers follow in case a future researcher wants to see the original data for some reason. Make sure to upload your data into the IDAH2O system as soon as possible. While the data on paper never goes stale, it's easy to neglect this important step. This is one of the most important aspects of science, to make the data available for you and others to see. Okay, now it's time to take the Module 3 quiz. We'll see you in the next module where we'll begin the process of learning about each assessment and how they work.